Hey, and welcome back. Today I wanted to play with these little relay modules I got on a mailbag, and I think the intention is you're supposed to use an Arduino to control these, but I don't want to use the Arduino. I want to use the sun. How am I going to do that, you say? Well, first let's figure out how these things work. And for that, we're going to need a breadboard. So this is the module up close here, and I don't know if you can see that on the silk screen, but the middle pin here says plus, the side pin here says negative, and this pin all the way over here, it would be better if I had a pointing instrument, says S, or signal. So the point here is for your Arduino, since it runs on 5 volts, this is a 5 volt right here, F5V DC. This is a 5 volt relay, and there's the output contacts, and here are the inputs. Now you need 5 volts on here, the middle pin, ground on here, and a signal here. You got a diode to show you if it's working, and you've got a resistor here and transistor, and I believe this is a Schottky diode. Now how this will work is that you give it 5 volts and ground, and then it looks here for a signal, and when that signal reaches a certain threshold, so on the Arduino you would say, you would call it a high output, 5 volts, then it would switch this relay, and the contacts here and here, instead of being connected, the contacts will switch to here and here being connected. Now, you can use a sensor to catch the sun and an Arduino, but I just want to show you that you don't actually need that. And that's why I've got the breadboard out today. So here we go. We need 5 volts in the middle. So there, and we need ground on the outside on this side. Okay, 5 volts and ground. I'll just plug this into my breadboard here and here. So there we go. Now this module is powered up, but it's not doing anything. I believe these two contacts, the two outside ones here and here, I believe those two are connected together when the relay is at rest, and then when you give it a 5 volts here, then it'll switch over to here. That means that if I use this yellow wire for a signal, and I put that into the 5 volt rail, we should see this red LED light up, and we should hear a click. Let's see if that happens. And no, because it would help if I powered up my breadboard. Let's try that again. Yeah, there it goes. See that red LED? See the one right down there? Right there. Okay, so that tells us it's working. But now, how are we going to switch this, right? How are we going to make it change? Well, I think the first part is to figure out at what voltage this becomes active. So let's do that now. Now I'm going to use a potentiometer as a voltage divider. Basically put 5 volts on one side, ground on the other, and then we can spin this to divide the voltage anywhere between 5 volts and ground. I'm going to use these 10 ohm resistors though, instead of just feeding it directly 5 volts on one side, because when you turn a potentiometer all the way to one side, it's like a short between these two, and the other way it's a short between these two. So we want to avoid that. So basically I'm going to use this 10 ohm resistor here, which I cut down to be a little bit smaller. Put that in here, say there, 5 volts to there, and I'm going to skip one because that's the pin spacing of the potentiometer. So skip one, and that's the wiper. Skip one, and we need it on 21 here. I'm going to give it a ground. So there we go. So now we've got 5 volts come in. It's going to be dropped a little bit by the 10 ohm resistor, but it's a pretty small resistor, so it won't affect it that much. This is a 50,000 ohm potentiometer. And then it comes out by 21 and to ground. So now I can set this potentiometer in the middle there, getting the correct pin spacing, like this. Maybe I'll go 2 actually. Go this way. There we go. Now we need to check the voltage on this potentiometer. So let me get a multimeter so we can do that. So I got my multimeter here. I'm going to put the black lead of the multimeter into the ground here, so we have a common ground for both our circuits. And then I'm going to take the red one and I'm going to put it into the wiper position of the potentiometer. So that'll be here. Just got to make sure that stays in there. Now if you see, if I turn it all the way one side, we get 4.996 volts, 997 volts. We get almost 5 volts. If I turn it all the way to the other side, we get basically 0 volts because most of the resistance is on that side of the potentiometer. When we go the other way, the bigger resistance is that side, so most of it's there. So let's turn this down so that at the wiper we get almost 0 volts. Now it's almost 0 because don't forget the 20 ohms, 10 ohms in, 10 ohms out. Now I'll take the yellow wire, the signal wire, and I will put it there. Okay, so now we've got the signal wire getting the same voltage as my multimeter. So I'm going to turn the pot slowly until the LED turns on. So here we go. We're at 0.7 volts, 1 volt, a little bit higher, 2 volts, a little bit higher, 2.4. We know at 5 volts it works. I just want, oh, the LED's on now, but the relay hasn't turned on. Keep going. Oh, there it goes. Back down. It's got a little bit of hysteresis. And off again. 2.4 off. So 2.4-ish volts off. And like 2. I didn't go slow enough. So let's go slow again. Just about 3 volts. So just about 3 volts it turns on, and then back below 2.4 it turns off. And the faster you go, the more decisive it'll be. Okay, so on, off, on, off, on, off. This is basically all that your Arduino does when you command a logic level high or logic level low. It just shoots up much faster than me with my little potentiometer here. So now I'm going to check and go up. I'm going to check the approximate resistance that we need on each side of the circuit. So it's about, let's say 3 volts for a decisive on, okay, for 3.2, whatever. So I'm going to turn off the circuit like this, whoops, okay, and I'm going to go into ohms. Now we're checking the resistance between here and here. So I have about 4.7 k ohms on this side. And on the other side, I have about 3.3 k. Okay, so that tells you that it's approximately half. Okay, 4.6 and 3.3. So it's just a little bit off half. Like let's say, to be safe, maybe 2/3 one direction, 2/3 the other. But now you may be thinking, well, what the heck does this have to do with turning on something with light? Well, let me tell you. This little device is an LDR, that is a light-dependent resistor, meaning it works just as a regular resistor except that its resistance value changes depending on how much light hits it. So I'm going to put this in the breadboard and let's see what it does. And there it is installed right there. It's a little hard to see, I get it, because it's white on a white background, but trust me, it's there. And here we're checking the resistance of it. I have my multimeter lead here on one end and here in the positive rail where the other leg is in. And if we look at this, we have about 240 ohms, but it is changing a little bit, and the reason for that is this is a very sensitive resistor and it is dependent on light. So it's pretty bright in here. It's 244 ohms. If I cast a shadow, look at that, 600 ohms, 700, 800 ohms. Okay, you see that? And if I really block it out, 1.1k ohms. It's just from the light, and it responds extremely quickly. And I even have here, I have a little USB light. I'm just going to put that over there. Look, you can get it down as far as 100 ohms, maybe a little bit lower, depending on what angle. Look at that, 99 ohms, 85 ohms. So basically, you get the point. It's a variable resistor. What else is a variable resistor? Well, that potentiometer we used earlier. So let's see if we can hook these two up together and make something that'll turn on and off this this relay with light. So here we go. So here's my new setup. So I have it here, the LDR, light dependent resistor, going between the positive rail and this, where this yellow wire is, and where my multimeter lead is, right there. And I have another wire link here going to ground, and in between these two will sit these two pins of the pot. So I'm going to put that there. Okay, and then this should be maximum resistance now. I turned it all the way this way, all the way counterclockwise. So here we go. So now we're having 0.3 volts reading right there. I turn that down. There we go. 4 volts there. Actually, negative 4 volts. I'm actually reading this backwards, so let me just switch these leads so it's easier. So I'll go. Ah, there we go. That makes a lot more sense. Okay, so 1.3 volts this way. Okay, and now just so you know, you adjust this, and if I want more resistance to go into here, I have to make it darker, right? So you set this to the luminosity that you want your load to turn on. So for example, maybe once it's daytime I want my sprinklers to turn on, so you would go out in the daytime, adjust this potentiometer so it would turn on, and then any luminosity below that will actually turn your load off. So if I cover the sensor, it just turned off. If I open it, it turns on. So let's say this is for real, my sprinklers, I want them to turn on, but I don't want it to turn on when it's cloudy. So I just adjust it to it's basically till it's just about at the point there. And then as soon as it's cloudy, as soon as the day becomes cloudy, it should turn off, and it does. So there you go. For a few cents worth of components, this is just basically a resistor divider, a 5-volt source, and your relay. You can control loads. Let me show you how the outputs work, and then if you're still confused, you can check in the description below where I will have left a circuit diagram. But trust me, it is extremely simple. So here is my setup. We've got a 9-volt LED with a power supply giving it power. So the wires go straight from the 9-volt power supply through the LED into these broken contacts here, which are normally open, so the circuit is not complete. Then this wire comes all the way back to the power supply through here. So now I have my finger on the sensor because remember, at the lighting at my bench, this is supposed to turn on. So let's see what happens if I take my finger off. And there it goes, it clicks on. And if I block it, so much that there's lines forming from my camera. There we go, fix that. And this reacts extremely quick. If I make a gap in my fingers like that, I don't know if that's fast enough, if the shutter speed is fast enough for you to get that, but there we go. So you control your load with sun. No Arduino necessary. If you're still confused, Check the description of this video where you'll find the circuit diagram, but if you download the circuit diagram, you'll see it's extremely simple. Thanks for watching.